Thank you. All right, good morning, everyone. Sorry for the delayed start there a little bit. We're figuring out a few technical difficulties, but welcome everyone to the March California Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thank you to those that have joined us previously and those that may be joining us for the first time. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NIDIS in California, Nevada. We co-host these webinars with the California Nevada Applications Program, who are a NOAA RESA team. This bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, I just want to note for folks that this webinar is being recorded, and the recording and a brief summary will be available on drought.gov and on the NIDIS YouTube channel later this week. And I'll pop that information into the chat so you guys can have that for later. We've got a great set of speakers this month covering current conditions and outlooks, as well as some conditions updates from UC Cooperative Extension and Nevada Bureau of Land Management. Speakers will be more fully introduced later, and I'm going to pop their information in the chat as well so you have their names and websites and things like that. Before we get started, just briefly about what is NIDIS in case you haven't joined us before. Our mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, and mitigate and respond to the effects of drought. We work to improve our understanding of how and why drought affects society, the economy, and the environment, and improve accessibility, dissemination, and use of early warning information for drought risk management. We fulfill this mandate given to us by Congress by advancing regional drought early warning systems, several of them you can see here, of which California and Nevada is one of them. And so lots of activities under improving drought prediction and forecasting, supporting drought planning and preparedness, strengthening collaboration, supporting drought impact assessment. And then we also lead the US Drought Portal, which some of you may have visited, which is www.drought.gov. Just a little bit more, what is a drought early warning system? It utilizes new and existing partner networks to optimize that information and expertise of all the different types of partners around drought, so we can make that information and data readily available, easily understandable, and usable for decision maker. Basically, we want to improve their capacity to better monitor, forecast, plan for, and cope with the impacts of drought. And with that, we'll hop into our agenda, which is why you guys are all here today, not listen to me. We're going to go through several presentations. The first will be Ben Hatchett from the Western Regional Climate Center. He's going to be giving the Drought and Climate Update, followed by the Drought and Climate Outlook from Nathan Patrick, who's with the National Weather Service California Nevada River Forecast Center, then followed by Rangeland, California Rangeland status from Leslie Roque at the University of California Cooperative Extension, and then an update from Nevada Bureau of Land Management from Patty Novak-Eschanik. With that, Ben, I will go ahead and pass control over to you to get started.
Cool, thank you. Okay, well, thanks for the invite to discuss our current situation, which I guess we'll start off with a really pretty picture of when things were looking up in the world, but unfortunately, as I'm sure many of you are aware, our conditions maybe are not going quite the direction we had hoped at the last one of these calls. So we'll talk a bit about that. Let's see, here we go. So I'm going to try to connect this with Dan's previous presentation to kind of talk about our progression, which from the US Drought Monitor, thinking about our pre-winter conditions, severe, extreme, and copious exceptional drought throughout the California, Nevada regions, following a wet fall and wet start to the winter, meteorological winter. Conditions were looking up quite a bit, with a lot of drought amelioration taking place in both states and some pretty exceptional improvements throughout California. However, the story is heading back to a re-emergence of drought conditions, particularly in far southern Nevada, the southern portion of the San Joaquin Valley, and the northwestern part of California as well as along much of coastal California. And the large reason for this reemergence of drought is the remarkable dry spell that we just experienced. So our current situation is shown in the blue line. This is looking at the 8-station index in Northern California. You can see we're off to a great start, on track for one of the wetter years, but then at the start of the new year, we essentially flatlined and have received very little precipitation in the subsequent months, with a, depending on the location, 30 to 60 or so day dry spell in there. And we've seen a little bit of precipitation more recently, but nothing to really make a dent, given the kind of missing out on the majority of our wet season. Looking at the stations across the region, using the Climate Perspectives tool, which I think is a really neat tool provided by the Southeast Regional Climate Center, taking the last 2 months from a couple days ago, and the precipitation rankings, all of those brown numbers are showing the ranking in terms of low precipitation. So the first driest, second driest, and so on throughout much of the California, Nevada region. So we're experiencing a very notable winter and early spring dry spell. The usual suspect is to blame, as we are very well familiar with, blocking high pressure over the Western North America region diverts the storm track poleward, driving our much needed precipitation into British Columbia and Alaska. So while they are dealing with too much water, we are stuck baking beneath this high pressure ridge that is preventing moisture and storms from making it to our region. As a result of this high pressure ridge, we've seen some interesting temperature extremes, both on the high side and the low side. And really that's fundamental to the quiescent synoptic conditions associated with high pressure. We get strong valley inversions at night with cold, clear, calm conditions and long durations of no sun, leading to a lot of cooling, but then we have ample daytime heating with no clouds, cold fronts and drier air, allowing for a lot of heating to take place. So we've seen a number of locations seeing some of their hottest maximum temperatures for their respective periods of records, and we've also seen some notable heat events, a couple different heat waves taking place. San Diego hit its all-time winter record of 91 degrees Fahrenheit on February 12th. Reno hit 88 degrees Fahrenheit, which tied its winter record. Reno also set 8 daily high temperature records during January and March. And so some of those were monthly records, but seeing a lot of high temperature records throughout this period of time. Also, consistent with the ridge, we've seen a lot of very cold temperatures taking place. So when you don't have a lot of mixing or bringing other air masses in the region, very easy to establish cold valley inversion conditions, and there may be some various impacts to crops, or if you left your hose hooked up and it froze, this is why. So average temperatures are a little bit above normal, but I really wanted to highlight the effect on the extremes, the maximum and the minimum temperatures as a result of this ridge. This high pressure is also driving a very thirsty atmosphere. So looking at two perspectives, the 8-week and the 4-week evaporative demand drought index, especially in Southern California and along the California coast. We have seen a very thirsty atmosphere. Nevada has done a little bit better, but you can see at the 8-week time scale, Southern Nevada is also getting kind of cooked by these conditions. Not as bad in recent months, and we are heading into Nevada's kind of one of its other wet seasons, the spring wet season, although we are expecting from climate projections a likely decrease in storminess in that region, with a blocking pattern continuing to persist. The reservoir situation, I think, is best described as falling behind. Unfortunately, I wish I could be a little more positive. And I suppose we could. We did fill up a lot of smaller bodies of water with our wet start to the water year, but our large-scale water supply situation in California is, in basically every case, we are behind in terms of our percent of capacity and where we expect to be percent of historical average. We're right about 50% of historical average at a lot of locations. Some places are better, Bullards Bar, Folsom, some of the smaller reservoirs, but places like Shasta is quite a bit concerning. And Oroville, which also fell into the dead pool range the end of last summer. So hydropower capabilities are going to be impacted by our current situation. State water project allocations were dropped in recent weeks from 15% of requested down to now 5% of requested. So that's kind of maybe bringing back memories of the drought periods several years ago. In Nevada, Lake Mead, we are not seeing a good situation either, with a rapid decline in Lake Mead levels. At its current level of 1,062 feet, it is continuing to find itself into new record low territory since its filling in the 1930s. It will hopefully start to fill a little bit as the upper Colorado Basin snowpack melts. However, this early downward trajectory is kind of similar to last year, and that's not very good. We maybe hope to get a little bit more of a springtime bump as we saw in 2020, but the runoff efficiency of the upper Colorado remains to be seen for the season. But the snowpack situation in the upper Colorado is a little bit better than in California and Nevada, which we will talk about now in terms of our natural reservoir, our great snowpack, the water tower of the West and the world. Was looking good. We had real high hopes, and it hung on pretty well given the very notable dry spell that took place, especially at higher elevations. But we had a lot of wind events and a lot of sunny weather, as we'll talk about, that really moved us from a quite happy situation with percentiles in the in some cases, pretty close to near record conditions, but well above normal for the time of year in January. However, our current situation can maybe be summed up by this photograph here provided by Chris Engelhardt down in the eastern Sierra Nevada. This is just outside of Bishop. This is pretty, kind of sums up what we're looking at here. Not a good situation. So now our percentiles, we were in those greens and closing in on some of the blues. Presently, we are deep in low to no snow conditions where we are below the 30th percentile of snowpack for the time of year. This is characteristically right around peak snowpack, depending on your location. It's plus or minus a few weeks from April 1st. In California, it's typically a little bit before before April 1st, kind of late March. So we're right there. And so we're not too thrilled to see a lot of these low to no snow conditions. And just for comparison to where we were, this is the effect of the persistent dry spell. It really drove us from great conditions to not so great. So again, expected peak SWE at this time of year. Couple photos from a few days ago, looking down at the Kirkwood Valley towards Lake Tahoe. Not exactly what I would expect things to look like in late March. This is more characteristic of late April, early May, and then further down on the west slope, 7,400 feet, peak snowpack in the Caldor Fire Burn area, not looking so good. So this is a very, unfortunately, common sight to see in many of California's mountains at present. So we would consider this to be deep into snow drought. And now with our third back-to-back snow drought year, that satisfies this concept of an episodic low to no snow condition where more than, or at least 3 out of 5 years are experiencing low to no snow conditions. And we're seeing that both in California and in Nevada. And in both locations, you can really see that early nice start to the year that put us ahead of schedule. However, following the dry spell and very persistent warm, sunny, and windy weather, we did not accumulate SWE, and we started to lose SWE about a month to a month and a half ahead of schedule in both locations. And so that's leading to a very rapid decline in our existing snowpack. As we have now satisfied the cold content of the snowpack, it is ready to melt, and it is melting fairly quickly in many locations. So if you blink this year, the conditions might have changed. If you went on vacation for a month, you could have gone from excellent conditions down into near record low, and then back up into record high, and then back into low. And so these are a couple phase diagrams. There's a new tool on the Western Regional Climate Center to produce these and to show, basically track conditions in a percentile space with respect to precipitation and snow water equivalent throughout the year. So this is showing Central Sierra Snow Lab on the left, Lamoille Canyon, Nevada, kind of eastern Nevada, northeastern Nevada on the right-hand side. And what we can see here is that we've really experienced the volatility that we are coming to expect as the new normal / jump off point, where we fall deep into snow drought way down on the bottom there, big improvements, and then the effect of the dry spell is to push us back into dry snow drought conditions at both locations. So really the key driver here has been this high pressure ridge that diverted the storm track northwards. That blocking ridge favored excessively sunny conditions. The colors on this map show the downwelling shortwave anomalies for the January and February time period using the North American Regional Reanalysis. So we see very, very sunny, much sunnier than normal conditions throughout the Western US. And that is helping to drive snowmelt. Solar radiation is the key driver of snowmelt. And to quote Kelly Redmond, drought is too many nice days. We've had far too many nice days this year. We've also had windy and dry conditions that favor sublimation. That's water that we do not get the benefit of as melt, even if that melt is at the wrong time of year. We just lose that water. So our snowpack is dwindling as a result. Soil moisture, things were looking good in January throughout much of the state. Central southern Nevada struggling a little bit, but some good improvement. However, at present, we are moving deeply into the dry, wet percentiles in both states. So not a very good situation there. And consistent with this early and rapid snowmelt, soil moisture is rising yet again, which is good. We like to see soil moisture come up. However, it is about a month early. Rapidly increasing, consistent with that melting snowpack, very similar to 2021, which is kind of the line that was at the actually record low soil moisture throughout much of the late spring last year. So we're kind of on a similar trajectory. We do have more saturated soils this year, so hopefully we'll see a benefit in terms of stream flow with a little bit better runoff efficiency as a result of that. But barring any late spring, April storms, our soil moisture is kind of on a trajectory to peak early and then fall quickly as we move into the warm season. Speaking of stream flow, here's our current situation in terms of stream flow percentiles for both states. Along the California coast and in central Nevada, stream flow is low where it shouldn't be. We want to see stream flow higher for this time of year, or at least closer to normal. And then we also see high stream flow percentiles, but also where they shouldn't be. We don't want to see early record stream flow in March. We want to see that in April and into May. So this is also indicative of that snowmelt proceeding about a month ahead of schedule. So we're seeing what snowpack we have left is now converting to runoff and stream flow and flowing out of the mountains in both states. And you can really see the Lake Tahoe Basin's pretty well highlighted there in both Nevada and California. As far as green up goes, we were quite green in January and February as a result of a lot of that soil moisture from early season precipitation. However, now we are starting to become browner and fuels are starting to cure throughout both states, as evidenced by those negative percent differences from average for the last 10 days or so. It is nice to see green up in recovery, especially in a lot of these post-fire environments. A couple examples from the Sonoma County region, the Nuns Fire 2017, and then we're seeing a lot of nice wildflowers blooming in a post-fire environment burned in 2020 during the Glass Fire. However, I think when you take a little bit more of a landscape perspective, up on a ridge, looking over the same area of Sonoma into Napa County, curing of fine fuels is taking place. You can see the grass is starting to brown up. And so we had that really wet start to the water year that really benefited the growth of the fine fuels, grasses and small shrubs. And as those cure and dry out, I think that's going to be something to think about now that we have a lot of fuel connectivity with some of the heavier dry fuels that did not recover at all from our dry spell. And with all of the fines that grew, that's going to lead to a lot of probably higher ignition probabilities as a result of this early drying of the fuels. On the positive side, there are some good things. Because we had that great start to the year, snow-wise, we had a really good ski season. There was a solid base that coincided well with the January and February holidays and the ski weeks. So I think there was a lot of recreation benefits from our start to the year, and good weather never hurts, getting people out onto the snow. We've also seen some really good conditions for good fire. Prescribed fire, pile burning, defensible space work happening both in the Tahoe Basin, right at the Nevada-California state line at Van Sickle Bi-State Park, and then some other work taking place throughout the state. An example from some work from the Good Fire Alliance, contributed by Nina Oakley in northern Sonoma County, doing some larger scale broadcast burning across the landscape. So still some benefits to our dry season. We were able to get some work done and do some skiing. So in summary, as we know, it's a boom or bust hydroclimate in the gold and silver states. Thankfully, we had a boom to start because it sure was a bust otherwise. Plenty of beautiful days, too many nice days, but thank goodness for what we got to start things off. Temperature-wise, we saw hot and cold extremes as a result of that persistent ridging, and consistent with that strong ridge, it was generally very dry with both extended dry spells and periods of lots of excess solar radiation for the season, helping to melt our snowpack and prevent accumulation. And so as a result, we have low to no snow throughout California and Nevada. Very severe snow drought conditions are continuing to emerge. And I think it's pretty fair to say we're now pretty committed to a third year of drought, barring some April mega showers. So with that, thank you very much, and I'll happily take questions at the end.
Thanks, Ben. I don't see any questions right now, and as you said, we will pop them in the end. If folks have questions that come up, we'll just pop them into the question and answer box on the GoToWebinar panel, and we'll get to them later. With that, I'll pass it over to Nathan Patrick for the National Weather Service California Nevada River Forecast Center. And there we go.
All right, thank you. Are you guys able to see my slide?
Yep, you should be good to go.
Okay. Well, record snowfall in the Sierra during December. Unfortunately, it was not equally felt throughout all of California and Nevada. While the portions of the Sierra fared better this year compared to last, this wasn't universal, and the precipitation was skewed towards the early part of the water year. Here we have a picture depicting the Diamond Range southwest of the Ruby Mountains, taken by Bruce Thompson. And you can clearly see here, March 2021, you had a pretty sizable increase in snowpack compared to this year. So this is something that we'll kind of be looking at a little bit of how snow that fell in some areas didn't fall in other areas this year and vice versa. All right, so the topics that I'm going to discuss are the Climate Prediction Center's official April to June outlooks, along with the drought outlook. I'm going to give a CNRC perspective on drought conditions and specifically talk a little bit about what we're expecting in terms of our spring runoff forecast. And then briefly, hopefully, just demonstrate some of our website features that are available to basically find data for an area of your interest. It's hard in something like this in only 15 minutes to try and highlight all of the areas that everyone's interested in. So hopefully I'll be able to show some things, some tools where you can get access to data that you might be interested in. So to start off, the official probabilistic ENSO forecast as of March 10th, 2022. The probabilities are derived using the model output, but also includes human forecasters' input to come up with a consensus forecast. The La Niña probabilities are indicated by blue bars. The neutral probabilities are indicated by gray bars, and the El Nino probabilities by red bars. La Niña's conditions are favored to continue into the northern hemisphere summer, after which neutral or La Niña is equally favored as we moved into the fall. This forecast is a change from earlier in winter when La Niña was favored to wane during the spring season. Unfortunately, observations have tended to indicate that this has not occurred. So as a result, earlier CPC outlooks have now turned drier and warmer for the region. The CPC seasonal temperature outlook for April to June indicates a 33 to 60% chance of warmer than normal temperatures for large portions of California and Nevada. The CPC seasonal precipitation outlook for April to June indicates normal precipitation for Southern California. Elsewhere, a 33 to as much as 60% chance of below normal precipitation is being forecasted. But something to keep in mind, normal precipitation is a relative quantity. So some locations typically don't get very much precipitation during this time period. And so that's probably what we'll expect is we'll get some time, we'll get some spring, summer precip, but it's not gonna really make a large impact. And so the overall seasonal drought outlook through June looks very similar to last year's for the region, with drought persisting. Matter of fact, this is, if you were to actually pull up last year's map, it's almost identical, except for portions of Arizona where things are expected to drought to develop, which it was not for last year. So just to recap, the Sierra water year precipitation to date. As Ben showed some of these slides earlier, precipitation snowpack was limited to basically the October event, which was, as in hindsight, was very beneficial, and a record wet second half of December. There's basically been little to no significant snowpack has been added since January 1st, and region-wide, January and February ended up being the driest on record. So looking at our current SWE and snowpack conditions, NRCS snow water equivalent percentiles for the period record ending on March 26th are shown. These are primarily SNOTEL sites with some co-op locations mixed in. At least 20 years of data is needed to be included in the coloring, and many locations have approximately 40 years of data. Orange, yellow, and red colors indicate SWE below the 50th percentile, while greens and blues indicate SWE above the 50th percentile. As expected, based on this winter's precip, SWE is below the 50th percentile in most locations. Hopefully you guys can see my arrow key now. Mountain ranges in Nevada, the Klamath, are basically much worse off this year compared to last year. Things have fared a little bit better here in the Sierra, and that's mainly due to the snowfall that we've had during the earlier portion of the year. But as we can see here, the percentile of record for this date is now also starting to begin to tail off. So looking at the the Department of Water Resources snow water content, the March 14th update here on the left indicated that statewide the snow water content percent of April 1st average was 56%. This was pretty much in line with last year, with the north slightly below up near Shasta, and the south slightly above last year's pace. Unfortunately, the warm weather this past week has resulted in melt across the region. Peak snowpack has passed, and all three regions have dropped approximately 10% compared to the April 1st average. Looking at some of the CNRC snow water equivalent, on the left, CNRC models are indicating SWE losses of about 3 to 8 inches over the last 7 days. On the right, CNRC model indication of SWE percent of normal as of yesterday. And as you can see, that we're basically going to be much below and extreme below for the SWE for the April 1st average. The takeaway, though, is that soil moisture this year is significantly better than past years, or the last 2 years for that matter. So we're expecting more efficient runoff in water year 2020 or in water year 2022. So looking at the current soil moisture conditions for the deeper soil column, percentiles for much of the region are in the 10 to 20% range. But for runoff, there are some green and blue spots in portions of the higher terrain indicating wetter soil moisture. Looking at the shallow soil column, moisture percentiles are a bit more promising, particularly in the Sierra. Other indicators of improved soil saturation throughout the fall and winter, we can see here a consensus of the Lake Tahoe basins. The black trace is the current year. The light green down here is the 2021. Red trace is 2020, and then this is the median trace showing soil moisture for those respective years. Once again, looking at the Truckee basins, black trace is the current year. The median is this green trace. 2021 is the red trace, and the cyan color is the 2020 trace. In Northern Great Basin, similar picture, black trace depicting this year, 2021, showing the really low soil moisture last year, and then 2020 in the cyan color. And as Ben indicated, we can sort of see over the last week or so this uptick in soil moisture, which unfortunately is coming earlier in our season, but on a positive note, we have plenty of room in our reservoir, so hopefully we'll be able to capture a lot of this runoff and store it into our reservoirs. And finally, looking at the upper Humboldt, we see the same sort of picture where the soil moisture this year is below where we were in 2021, and the purple trace here in 2020. So the beneficial precip in October and the snowpack accumulation in December has allowed soil moisture to be above both water year 20 and 21. At the CNRC, we are optimistic that despite having a below normal snowpack, runoff efficiency should be better compared to the last 2 years. So looking a little bit at the CNRC water year and seasonal runoff forecasts. On the left is last year's water year observed flow across the region. Most locations were extreme below in the 20 to 40 percentile range of normal range. This year, the water year forecast Ensemble Streamflow prediction amounts look a little bit better, but still much below normal. However, the forecast is skewed towards the October to February portion of the water year. The October storm and December precipitation has skewed the water year volume much earlier. We can see this when we look at the seasonal flow forecast for April to July. So despite having a wet early portion of the water year and increased runoff efficiencies, region-wide forecasted April to July runoff is similar to last year. Portions of the central and southern Sierra are doing better this year, but locations across the Shasta region, the Klamath, and the Humboldt are forecasted to have below last year's AJ runoff. And with our earlier melt that we've been experiencing over the last week or so, we have seen significant melt the last week. Warmer temperatures will begin to return after today, and so many locations will experience their peak flow in the middle of April, and may even, if it warms up quickly after today, may actually be before these dates. So with that, I'd like to demonstrate some of the data that is accessible through our website. So let me pull this over here. Hopefully you can see this. So some of the data that I just provided are here in the water resources. So you can pick between different years if you want to see different years. This is our Ensemble Streamflow prediction water supplies for both the year as well as the seasonal. We have monthly accumulation flow data that you can get to, and you can see this by year. And then we also have reservoir storage. So you're able to basically look and compare for different places that you might be interested in different years. In addition, we have some information on snow data that you can look through, and you can see how we're simulating basins in our models for looking at our different snow data. But what I really wanted to focus on was this ensemble map that we have here underneath rivers and reservoirs. And this is so where you can actually get a specific site location, stream flow, ensemble-based prediction of what we're expecting for runoff to be. And so just to bring up an example, the Central Valley Water Resources Index, if you were to actually click on this dot, you can get seasonal trend plots, a water year trend plot, a water year accumulation volume, the multi-year water accumulation volume, and historical flows. So if I were to just click on one of these and do the seasonal trend plot, You can see how the progression of the stream flow through the year through our ensemble-based approach. And this will take into account the forecast that's coming up. So the next 6 to 10 days will be in here, and then it uses climatology after that purposes. And so you can see how we are doing in terms of the record flow, as well as the median flow, and where we expect things to be as we move through the water year. You can also look at other years for comparison purposes for the locations that you're interested in. And then you can also, like I said, do it for the water year trend plot, so you can look and find the data. And all of this data then is, if you click over here, you have the ability to grab a PNG. You can also pull the data down in a CSV or XLS format for your use. And so it's a pretty useful tool for anyone that may be looking at specific data in an area of interest that they're looking at. Looking at the water year accumulation volume here for the Central Valley, you can sort of get the minimum trace, you can get the maximum trace, and then you can also get where our official median forecast trace, which would be as of today for the Central Valley. And then something that's kind of, I think is kind of useful is looking at multi-year. So we're in the third year of this drought. And so you can see when I pulled this up actually this morning, I was kind of a little bit surprised because it dropped from yesterday. And so now we're actually, the period of record here is from 1980 through 2020. That's where we run our ensembles against, is this 40-year period. And you can see that at least in terms of the Central Valley Water Supply Index, we may be flirting with the possibility of the record low of accumulated volume. I guess previously the low was in 1990 to 1992. And so I guess that's a little bit surprising. We were doing a little bit above that before the weekend, but now we're actually perhaps are going to flirt with being at the record low. And then lastly, this historical flows tab is pretty good because it'll show the water years accumulation periods and where it was for at least for this location. And you can sort of see these 3 years again where the flow is well below this. So I just wanted to share with this that this is available. You can also see it via seasonal, and how you get to that once again is you can go back to our main page. And if you were normally, our main page would show up like this, which shows our daily forecast. But if you actually just come down here, unclick rivers and reservoirs and click on the ensemble points, you then can select from any of these points in either Nevada or California and get specific data and information for the location that you're interested in. And with that, I will end my presentation.
Great, thanks, Nate. I'm going to give you one quick question while I pass control over to Leslie. Someone said, great presentation. Are the KML files available from your website updated dynamically? Can you output KML files as dynamic data that is specified by the user on your website to input into GIS systems? Thanks.
I don't know for all of our products if it gets updated every day, but I do know that our processing does, yes. So I guess the overall answer is yes, but maybe not for everything, but we do regularly update it.
Great, thanks. And then a few more questions came in for both you and Ben, but we'll get to those later. So at this time, I'm going to let Leslie take over, and she's from UC Cooperative Extension.
Thank you. Can you see my screen okay?
Yep, it should be good to go.
Awesome, great. Okay, so I'm going to give a very brief update on California rangeland conditions. Currently, how this year's precipitation has impacted forage conditions across the state and how it may continue to impact going through the coming season. To give a little bit of, there we go. Just give a little bit of the California context. California rangelands are incredibly biologically diverse. They span a diversity of environments, range types, and climates, spanning from desert to semi-arid to Mediterranean. And a lot of our major rangeland systems can be both, we have annual systems, such as annual grassland and oak woodland. They're dominated by annual grass species. And we also have very important perennial systems, such as the higher elevation mountain meadows and intermountain areas as well. This, in California, this diversity supports what we call transhuman ranching, where livestock are moved between pasture-based forage resources in a seasonal cycle. And typically that means from those lower elevation annual grasslands and oak woodlands in the winter to those higher elevation mountain meadows and perennial grasslands in the summer. And as you can imagine, this creates interdependencies across the state between these different systems. And really the majority of the base ranching operations in the state are located in those valley and foothill annual grasslands. So they're really critical to the overall system. California's annual rangeland can be particularly challenging because productivity is extremely variable, in part because the plant community phenology is dynamically linked to seasonal weather patterns. So, a key challenge is that our optimum temperature and moisture conditions for plant growth are really out of sync with each other in this system. So this graph kind of shows, in a typical year, if all goes well, the annual rangeland growing season, it starts in the fall with fall rains, kind of that September through December period. And then during winter, plant growth, of course, slows due to lower air temperatures, lower solar radiation. And then as we move into late winter, early spring, so that February through April period, we see the initiation of that rapid growth period as air temperature increases and solar radiation intensifies. And then as we move into mid to late spring, which can be depending on location between April and even June, following that rapid growth stage, we see plant production kind of tables off. We see it reaches a peak biomass once that root zone moisture is depleted. Now, of course, this is a typical year. And in the past 2 years, we've seen that peak production reached much sooner and at lower levels of total productivity. And so this can result in extremely high spatiotemporal variability in forage productivity due to both that characteristic climatic and biophysical diversity and the dynamically linked phenology of the annual system. And this is an example site on the Central Coast in San Luis Obispo County, actually it's two different sites over 2 different years. And forage production, can vary by as much as 4 times or even greater, as you can see here, both, between years at a given location and even in a given year at different locations. And of course, this variability is further increasing as climate changes. And we're seeing increasingly large year-to-year fluctuations and instability of the forage supply. And this, especially given, the projected warmer and drier climate and increasing trends that we see in weather extremes. So communities reliant on these systems are, potentially some of the most vulnerable to climate variability given their dependence on such a highly climate sensitive resource. And so coping with and adapting to drought is critical to the sustainability of these operations. And, this was particularly exemplified during California's statewide, what we then called historic drought just a few years ago. So a little bit about where we are now. We've heard quite a bit about already, of course. Drought conditions continue to persist. This is the 2nd year in a row of worsening conditions. In many parts of the state, conditions are actually quite a bit worse than they were a year ago at this time. So in order to streamline and kind of help get on the ground observations to the U.S. Drought Monitor and to other decision makers, we and UC Cooperative Extension several years ago, actually starting in 2018, we put together a California drought coordinated reporting online reporting system that was heavily based on the CMOR, the Conditions Monitoring Observation Reports. And we targeted it to specific questions on range and pasture and circulated it to county range and livestock advisors and other rangeland professionals across the state to really help them kind of ease their reporting of local conditions on, based on their on-the-ground perspectives to the U.S. Drought Monitor and DEWS as well. So I'm going to give a really brief kind of tour of the state and do some lumping of regions, but these are some updated reports that we received in the last couple of weeks, actually just received last week on some of these as well. So starting in northern and northeastern California, so thinking Siskiyou, Lassen, Modoc counties, conditions there are moderately to severely dry, particularly for Siskiyou County. It's still a bit early for northeastern California right now to call that. In general, we're getting reports of reduced forage production, lower stream flow, and of course some irrigation curtailments, particularly in Siskiyou County. To give you an idea, that bottom photo is a small grains trial that was planted by a cooperative extension advisor, and that was planted in October, and that photo was taken just last week. So really impacted productivity there. On the north coast, particularly thinking Humboldt, Mendocino counties, reports of moderately to severely dry, reduced forage production, particularly in Mendocino County. Some of the infrequent rainfall that they've been experiencing and has contributed, hasn't significantly contributed to increases in stream flow or soil moisture. So they are seeing low soil moisture and poor soils and south-facing slopes, but particularly in Humboldt County, conditions have been slightly improving with those infrequent showers, but they still are in substantial deficit. For the Sierra foothills, we're getting reports of moderately to actually pretty severely dry conditions. Grass is maturing about 1 month early. The photo on the right here is a stand of Medusa head grass that typically we don't see it in full inflorescence till about mid-May. We're also getting reports of soil moisture more typical of what folks are typically experiencing in like late April and May. Part of the year. And so we're seeing reduced forage production, some seasonal creeks and ponds going dry. In fact, some that were actually had actually flowed in even just 2014, but some reports of some of those streams going dry this year already. And so in terms of impacts on the ground, we've already heard of some ranchers are selling and shipping livestock early again this year, similar to last year. For the Sacramento Valley, we've been getting reports of severely dry conditions. Grass is maturing even more quickly than in the foothills, about 1.5 months early. So reduced forage production, decreased livestock condition. Folks are shipping cattle early. As one of the reports said, they're pretty much done in Glenn County in particular. They've also had reduced stream flow and water allocations. In fact, one of the local irrigation districts will distribute 0 water to customers this year, which is something that has actually never happened before. And these are particularly striking because they are the local district is a settlement contract district, so predating the CVP. And the San Joaquin, this is a site in Merced County, actually at UC Merced. They're reporting this moderately to severely dry conditions with, again, grass maturing about 1 month early. There's some small grains that aren't going to make crops, so they have been working with local producers, particularly sheep producers, to graze some of those stands. And then in general, just reduced rangeland forage production. And then lastly, on the central and south coasts, we've been partially for several weeks now, reports of moderately to severely dry conditions. They've had very little rainfall since about January, and grass is maturing about, again, 1 month early. And so they've seen significantly reduced forage productivity, and with some ranches reporting, particularly in Monterey County, that they've been selling and shipping livestock significantly early this year. So, it's kind of a general whirlwind tour of the state in terms of rangeland conditions. Just wanted to acknowledge the contributors from UC Cooperative Extension from this report today. In some, current conditions in the foothills, the valley, and the coast ranges that are critical for the winter and particularly spring grazing are really significantly worse than what we had experienced this time last year for many areas. We actually had a little bit of rain today in California, but as we heard earlier, we're already at quite a deficit. And with forage progression so far being advanced 1 to 1.5 months early, it might be too late for many places to have an impact in terms of a boost in regrowth capacity. And that's all I have today. Thank you.
Great, thanks, Leslie. I always appreciate you guys coming on here, but it's always so sad for you guys. And there's a lot of the early green ups and the drying out and everything. So hopefully we'll see how things go here, but it doesn't sound too good. So, but thank you for sharing all the different regions. With that, I'll pass it over to Patty from Nevada BLM for our last presentation. There we go.
Okay, can you see it? It's not switching over. There we go. Can you see that?
Yep, you're good. Yep, you should be good to
go.
Okay,
good. I'm Patty Novak-Etchnik. I'm the State Range Specialist for BLM Nevada in the Reno office. So I'm going to give you a big tour of Nevada, like Leslie did California. And one of the things I won't go over this slide too much is that Nevada is the driest state in the nation. We average about 10 inches of rainfall, and it's the 7th largest state. So we have extremes in elevations. Boundary Peak on the California border is over 13,000. And then on the Arizona border, Colorado River. So we have very much extremes in our vegetation communities and also our precip, ranging from a minimum of 3 inches of precip in southern Nevada to a maximum of about 40 at Mount Rose near Reno. So what is our climate? Well, we sit on the lee side of the Sierra Nevada, and that is a big barrier to those storms. We're hoping those storms come over today to Nevada. Haven't seen any right now. We usually get about 3 feet of wind rather than any moisture. Most of the precip comes from fall, winter, and spring moisture, and that's what's effective precip for the vegetation communities that we have in Nevada. The Rocky Mountains will block that moisture from the Gulf of Mexico, but we do get some monsoonal moisture called the North American monsoon from the Gulf of California during July and September, and it can bring strong convection storms, so much that we actually see warm season grasses down in southern Nevada that will green up and produce abundant forage when we do get those. Okay, so just a quick look at some of our climate. This is on the left, January through March percentage of precip. So Elko, you can see, is a lot of precip from December through May. About 32%, 30 to 40% actually falls from January to March. Austin is in the middle of the state. It also receives about the same amount of that 30 to 40% precip. Okay, in the summer, if you look at the summer, very dry. Reno has very little summer moisture, but Caliente, Nevada, down in southeastern Nevada on the Arizona or Utah border here, actually gets 27% of their total precip during July, August, and September. And you can see how California here gets very little during this time period from July through September. Okay, so if we look at the precip from September to February, again, remember this is our effective precip. Right now, Reno has almost 7 inches of rain. And during that time period, the average is a little over 4. So we're actually seeing some good green up. I was out in the field north of Reno last Wednesday, and we've got grasses growing. They're about 6 inches tall, and we have some annual wildflowers coming out. But the roads were dry, so the soil is fairly dry out there. Elko is almost near normal for that time frame, although I have had reports that the soils are very dry over there, but they're just starting to green up. We're still early. Austin, in the middle of the state, is a little below what we normally get, and Las Vegas is very dry. Okay, and if we look at our veg DRI, the beginning of the month, much of the state was still in out of season, very dormant. Where I live in Western Nevada, I was seeing green up actually in December from some of those December rains and snow. But as you look, this is March 20th, we're actually starting to show green up. I've seen aerial flights of some of the green up of some of our non-native invasives of cheatgrass and burr buttercup, red brome. Southern Nevada is showing some green up, but already drought stress. So if we look at our growth curves for the different communities, we've got our salt desert shrub, which is the low valleys, and the Mojave starting in mid-February, peaks out in April. As we go up in elevation, we'll see the Wyoming sagebrush coming a little later. Our mountain big sagebrush in June. This is peak growth. Here's our meadows, and then our highest elevations, our aspens, our firs. They don't peak until July. So we really look forward to more moisture. Here's some of our main forage grasses. The Columbia needlegrass, Letterman's needlegrass, these are typically in our higher elevations. Aspen stands, again, they don't peak until about the middle of July. Basin wild rye, blue bunch, these are all deep-rooted perennial bunch grasses. They're a little bit later, or earlier actually, around July 1st. Thurbers, Indian ricegrass, bottlebush, squirreltail, and sandbergs. These are our earlier grasses. When I was in the field last week, the bottlebush, squirreltail, and the sandbergs bluegrass were just beginning to grow, just starting to grow. I've had pictures come in from Elko that just showing start of this green up of these little grasses. But then they dry out early in the season. Okay, so we'll just give you a whirlwind tour of some of our rangelands. They are more shrub dominated than California. We don't have that annual grassland component in Nevada. So Southern Nevada, the creosote bush scrub is right now, Vegas has only had about a ½ inch of rain. They should have had over 2 inches of rain by now. And the annual forbs that are really critical for desert tortoise are going to be lacking this year as they were last year. I did a training down there last year, and we actually had very little growth in any of these shrubs. And the tortoise are out right now, so they really need those forbs, but I don't think there's much showing. And then as you go up on slope, you will get different plant communities, blackbush scrub and mixed desert scrub. And these will have some of the warm season grasses, the big guyetta grass and the blue bunch, or the big guyetta and the bush muley. We also have Indian rice grass and needle grasses down there, desert needle grass. But they probably are not showing much growth. Here's our salt desert scrub, which is mainly in the valley floors. So we're going to have winter fat, Indian rice grass, and some black greasewood. These are all forage species. These cattle are adapted to eating these shrubs, and this provides great winter feed for a lot of the producers in the eastern part of the state. So some of our early shrubs in that salt desert community, bud sagebrush. This is a good little forage species. It greens up early. I saw this one greening up in December where I live. So it should be about blooming by now. And this is another one, shad scale scrub. Let's look at spiny hop sage. Here's another one in that community. What I wanted to point out though is, see how it's not completely growing, a lot of dead spots. And these shrubs have those adaptations to die back, only produce a little bit of growth or stay completely dormant during these dry periods. They're used to drought. A lot of them live at least 50 years or better. And so they've seen it all. They've been out there a long time. So, and here's our Indian rice grass, also can be fairly long-lived and survive these droughts. As we move up in elevation, we have our Wyoming big sagebrush communities. Oftentimes there might be some of the salt desert shrub mixing in. We've got some winter fat. We might have spiny hop sage out here. And then our little Sandberg's bluegrass is in this community as well. Okay, as we go up even higher, the pinyon juniper woodlands. Juniper comes down, it's our drouthier of the two trees, so it'll be down to 10 inches, and then pinyons up above. But we have very old growth juniper in Nevada as well as pinyon. Some of the carbon dating that's been done by the Forest Service found some of the junipers up to 1,100 years old. So they've also been through a lot of drought. Okay, and next is our mountain big sagebrush and low sagebrush communities. These communities are forb rich and they are just starting to grow now. There'll probably be some of the forbs coming up, but they peak growth in July, usually June or July. And these are valuable communities for the greater sage grouse. They produce a lot of forbs that the little grouse chicks need, as well as the insects. And just a general look at our landscape and how these communities are laid out. This is the Shell Creek Range out of Ely, Nevada on the Utah border. We have Mount Mahogany, very old trees on these rock outcrops, a low sagebrush community that's mainly a runoff situation. At the foot is the Aspen Woodlands. It's probably a snow pocket, also receiving moisture from up above. This is deep, fertile soils. These communities do not peak until July, usually. And then our mountain big sagebrush. You can see a lot of the tall grasses, basin wild rye. There's probably some of the needle grasses and some snowberry here. And then, of course, at the very top, we have aspens and pines, firs. We've got Engelmann spruce, Mount Mahogany, believed to be about 3,000 years old in some areas of Nevada. And we have an assortment of different meadows. We have saline meadows that are sawgrass and alkali saccatone. This is actually down in Beatty, Nevada, about 2 hours north of Las Vegas. And so we do have meadows where there's high groundwater and springs and seeps. The Humboldt River provides a lot of forage for the producers. They actually will mow these riparian meadows for winter feed. And then of course we have our high mountain meadows, which are not grazed until usually June or July. And then of course our alpine areas. And I looked at some of our cameras, our fire cameras this morning, and there's still snow in some of these places, but again, they are melting off. This is actually Mount Moriah and the Snake Range over on the eastern part of the state next to Utah. And this is the Spring Mountains out of west of Vegas. Actually, we have some alpine areas there. So our ranchers are taking non-use. Some of them are actually taking some non-use, or they're doing later turnouts, hoping for more rain. A lot of them have been water hauling just to aid in distribution. We did have some snow cover in the eastern part of the state where we had to have some emergency feeding, where the rancher had turned his livestock out on the rangelands, and he had to spread snow because there was 6 inches of snow, or spread hay because there was 6 inches of snow. So we have all different varieties of rangelands, and so the ranchers just make do with what they can. We're always hoping for more rain and snow. So let's hope we get a little bit more in the next month or two. Thank you.
Great, thanks, Patty. I'm going to take control back over here.
I don't know how much time I took. We're a little over.
Yeah, no, for folks on the line, thanks for staying around. It's my fault that we're a little behind since I had some technical difficulties at the beginning. So if you did answer a question, I think what I'm going to do is just answer them via email. So I will connect you with the speakers and get to your questions, the folks that have them in there. So here I'll just probably again just close out the webinar instead, and I'll follow up with each one of those questions that are in there. First, I just want to say thank you to all you for joining us today, and to all our great speakers for sharing. There's a lot of great information, and it's an important time of year to get that information out. So I appreciate all you guys and your presentations. I'll mention again that a recording with a brief summary of the webinar will be available on drought.gov and the NIDIS YouTube channel later this week. And lastly, I'll just mention that our next webinar is scheduled for Thursday, June 2nd. So you can't quite sign up for it yet. Normally I have all the webinars set up, but we're shifting the day and the date in order to show you guys better the fire outlooks that come out June 1st. So normally we had the webinar at the end of May, but we realized having it after June 1st makes more sense. And so the next webinar will be June 2nd, and we'll send out information on that soon, but it will be fire themed, similar to what we've done in past years, where we'll have the fire outlooks, fire information, things like that available and things like that. So more information on that soon to come. Otherwise, I think I'll close it there and say thank you again for everyone to joining with us. I'll follow up on all the remaining questions. And if you have time, we do have a post-webinar survey where you guys can tell us what you guys want to see on future webinars. And with that, I'll say thanks and hope everyone has a good day.